Yeah, so welcome. Happy that you guys joined today's session about mastering resources on the Azure platform. And in the next 45 minutes, I will talk a little bit about, well, my or our experience, how we work with customers or used to work with customers in the past, because we all know that, well, provisioning resources in Azure is a pretty simple process. But to really master resources onto the Azure platform is much more complex. And this is what I will talk about in the next 45 minutes. Now, I presented kind of a similar session before, but I totally restructured it. So this is the very first time, actually, that I present this deck and also the demos. So I'm really curious about your feedback at the end. Through the chat channel or also through social media or by email or whatever, so you can tell me, well, if you like the approach, because it might be kind of a little bit of different approach that you might have heard before. I will also not talk you to death by mentioning the Microsoft Cloud Adoption Framework and things. It's really just my very simplified approach, how I see things and how resources should be managed and treated in the Azure platform. All right, so my name is Marcel. I operate out of Switzerland and I work for SoftwareOne. I'm the team lead of a cloud team that assists and helps customers with everything Azure, M365, and security. And myself, I mainly work in the Azure space, so I help customers when it comes to onboarding to the Azure platform with all the preparation work, with things such as, well, preparing, designing, and implementing landing zones, either manually or preferably, of course, using automated approaches. And then, of course, we assist them in bringing existing applications onto the Azure platform or build brand new solutions that might be cloud native. All right, so what will we cover in the next 45 minutes, or how should you actually approach Azure when it comes to resources? And if you break it down a little bit, it comes down to these four pillars. And just to be very clear here, I will not talk today about whatever application architectures or landing zones and things like that. I will only focus on a very simple example to show you how you should approach different resource types in Azure. And when we focus on Azure resource types, then it really boils down to these four pillars here. So before you implement something, you should really make sure that you understand how a resource works, so the characteristics of a resource. This is very, very often not done properly or not done at all. But to me, this is the absolute most important pillar of these four. And then once you understand how a resource actually works, you can think about, well, how do I want to govern future resources of that type? So what do I want to implement to make sure that I have these resource types under control all the time? And then once you have that, you, of course, deploy the resources to the Azure platform. So this is when the deployment actually starts. And then, of course, normally when we talk about deployments, it's not about deploying a single resource. It's then deploying like a set of resources that might form an application or something. And once it's deployed, it's all about managing the resources or the applications. So how do I manage that application and the resources on a day-to-day basis? So these are the four pillars you need to take care of. And then you're pretty well equipped to master your Azure resources. Now let's dive into the different sections. So what do I mean here when it comes to understanding Azure resources? As I said, this is very often not done properly, but it's very, very important. And understanding means, of course, that first you need to understand a little bit about the resource type itself. So I will show everything today with my most favorite resource type in Azure, which is Azure Storage Accounts. Why is that my most favorite resource type? because it's simple and it allows you to explain everything because it contains a little bit of everything that needs to be explained, but you can easily adapt this to any other resource type. So it's important that you understand how that resource type really works, how you want to use it, why you want to use it, and what configuration options you get. So this is just for you to understand the resource a little bit better. But now when it gets really interesting is the following things. So one topic you need to understand is how can you authenticate against this resource type? And when we talk about accessing resources, we normally always talk about the so-called control plane or management plane and the data plane. So the control plane defines who can deploy the resource, who can manage the resource in the Azure platform, right? And then the data plane is the definition how the resource can be used. So when you start using a resource such as a storage account, how can I access the content that lives in the storage account? How can I read data from that storage account? How can I upload data to the storage account? And you need to understand the different authentication methods for every single resource type that you're using. And why is that important? Of course, because you need to assign proper permissions so that people that either manage that resource or use the resource have proper permissions, exactly the resources they need, the permissions they need. And for that, we obviously always follow the principle of least privilege. And very often, when I talk to customers about giving access to a resource, it stops after we discussed how RBAC works. I mean, RBAC, role-based access control, is an important thing because it uses Azure AD users and groups to assign permissions. But more or less every resource offers more than just an Azure AD authentication when it comes specifically when it comes to the data plane. So there's resources that offer access keys to authenticate against. There's resources that offer local passwords that are stored in the resource that you need to authenticate. And you need to understand all of these different authentication methods for your different resource types. And why is that? Because you need to handle them. Now think about an administrator that leaves your company. So what you're doing normally is you just disable his Azure AD or his Active Directory accounts. And this is fine because for many of the authentication methods, those use Azure AD and Active Directory accounts. But there's other authentication methods as well you need to take care of, such as access keys, because if my Azure Active Directory account is disabled, but I still have an access key, then I could still authenticate against a storage account, even from the outside of the company network or the company environment when that storage account has a public endpoint. So I need to be aware of the different authentication methods that are available for a resource type and how I want to manage those. And I will talk a little bit about that later. Then, of course, encryption. We need to understand encryption, an important thing for my resource or for my service that I will deploy later. And I need to understand how data at rest is encrypted, how data during processing is encrypted, and how data in transit is encrypted, so that the data is encrypted and safe wherever it is actually sitting or wherever it is transported. And you also need to understand about what algorithms are used and what keys are actually used to encrypt the data. And when it comes to Azure services, you will very often see that you can get in control of the key encryption keys of the different services. And you need to make a decision, is this really something you want? So do you want to take care of managing key encryption keys, or is this something that you want to hand over to Microsoft so that they can take care of that? So encryption, also very important part. Then endpoints. Whenever you deploy a service in Azure, you need to understand if that service uses a private endpoint or a service endpoint, or if it's a total public endpoint. Now, public endpoint means that this service is reachable from the internet, so from outside of our environment. That means that if you have a service that needs to be reachable because it's maybe a web app or a storage account that has public data, then of course that service might need a public endpoint. But public endpoint also means that it's reachable on the network layer from the internet. So even if you're not sitting in the company network, you can reach that service. And of course, before you can use the service later, you need to authenticate. This is where the endpoints and the authentication methods now play together, because if you have a service that has a public endpoint, so it's reachable from the outside, and you have different or various authentication methods, such as access keys that are not disabled when I leave the company, then that combination means that I can obviously access this storage account from the outside with an access key I still have from the time I still used to work for this company. And then I can authenticate and get access to all that data. So I need to be aware of what this means to have public endpoints. And of course, you can restrict public endpoints, saying you can restrict the source IP addresses so that not everyone can access your public endpoint, but only certain source IP addresses that are trying to reach your service. And then, of course, there's also a way to completely disable the public endpoint. So, for instance, if you know, well, the only consumer of my storage account, for instance, might be a virtual machine that lives in a virtual network in Azure, then you can link your storage account using a private or a service endpoint directly to that virtual network subnet. And then you can shut down the public endpoint completely, which means that your storage account will only be accessible from within your private network. So this is also something you need to understand, how to deal with these endpoints, because we see a lot that services are provisioned with public endpoints, and the only reason is just no one cares about those. But then those services are exposed to the outside world, and that's not what we want. Then, of course, you need to think about the protection of your services or of your resources. And for that, we have Azure Security Center that scans our resources on a regular basis and gives us recommendations how to secure our resources just in case they are not secured from the very beginning. And what's important here is to understand before you deploy a service, are there maybe certain features available in Security Center that are delivered maybe by Azure Defender that could be interesting to protect our resource types later. So also be aware of the protection measures that the platform gives you. Then, of course, it's all about availability. If you use a service, you need to understand, well, what's the SLA that Microsoft gives us for using this service? If I use that service to store data, is that data stored in a redundant way so that if a server breaks in Azure, that my data is still available? What if a data center goes down? Is my data still available, or are there other availability options I could use to enhance the availability of my resources? Right, and then we have monitoring, because of course, if you provision resources onto the Azure platform, you need to understand, well, what types of log files, events, or metrics does this resource type generate, and are those of interest to us? And then we need to decide, well, what are we doing with that data? So do we want to create alert rules so that we can see alerts in case a specific event is generated or a specific threshold is reached or something? And what happens if that alert is generated then? Do we want to send out a notification, or do we want to trigger an automated action that might maybe fix the problem? So those kind of things need to be defined as well. All right, and finally, we should also think about the operational tasks. So how do we operate this resource afterwards? Are there recurring tasks that need to be executed manually, or of course, even better, in an automated way? Or are these operational tasks to maintain the resource that are triggered maybe from an ITSM system? Because in there you might have operational or maintenance tasks defined, and based on a ticket that is created, those could be triggered in the Azure platform. So lots of things you should understand before you actually provision a resource. I think that's the most important thing. All of these slides I have just shown you, you should take care of these areas and these bullet points before you provision a resource, so that you are ready and you understand how to handle the resource as soon as it is living in your environment. And now this is just an example how you could approach this. So what we normally do is we have descriptions, or let's say tables, for every single service that we are using for our customers. And this is just an example for a storage account. So you can see here, for instance, this is the authentication section. And we defined, okay, there's the control plane and the data plane. For the control plane, we use Azure AD RBAC, for the data plane as well. But then for the data plane, there's also other options, such as the access key that every storage account has, or shared access signatures, and so on. And then we define, well, what would happen if I would want to block a user from actually getting access to this storage account later? Well, if you are using the Azure AD RBAC, then it's easy. You just disable the account. But what about the access key, for instance? There you should think about, well, would it make sense to rotate this access key every now and then? So even if someone leaves and still has the access key, that this cannot be used like. So, and that means that if we decide to use key rotation for the access keys, we need to come up with the solutions how we want to address this. And then, of course, also how often we want to rotate the key. Is that every week? Is that every day? Is that every hour? And what happens if I rotate the access key? What happens if someone actually, or an application, uses this access key? Then that application will break. So I need to think about, well, if I rotate the access key, it will make sense to store that value, that new value, in an Azure Key Vault, and then instruct our applications to pick up the access key value from there. So you can rotate all the time without breaking your applications. And then the same is true for encryption, for endpoints, for operational tasks, and so on. So this is just like a parts of such a sheet. Right, and everything that's orange here is then, for instance, can be marked as critical. So access key handling is a critical thing. In transit data encryption is a critical thing because it should definitely only allow encrypted traffic. So HTTPS only, but not HTTP. And so on. So it's up to you what is critical and what is not. And then you repeat this for every single resource type you want to use in the future. All right. Good. Now, as you understand the different resource types, it's time to start governing the resources. And here you need to think about compliance. So are there any specific business rules I need to apply to actually, well, use my resource so that it's controlled, that it's governed all the time? And the business rule, for instance, could be, well, if we define that HTTPS for storage accounts is a critical thing to us, then the business rule could be, well, please apply HTTPS and to all of your future storage account as a mandatory setting. All right. And then we can decide if this is something in the future that we want to assess, which means that shall we assess all our storage accounts that live in our platform if they're using HTTPS for securing in transit data? Or is this something we also want to enforce, which means that if you deploy a new storage account and you, for whatever reason, you select the option to not use secure transfer, then that deployment would fail because it's not allowed. That business rule is enforced, right? And then, of course, at the very end, I want to get a nice overview of my compliance status where I can immediately see, well, are all of my storage accounts compliant to my business rules, or do we have non-compliant situations? Now, for implementing those business rules, we have Azure policies that we can use. And the cool thing here is that Microsoft gives us, well, a vast list and catalog of pre-created definitions that we can just use. If you have a little bit of, like, let's say, more complex requirements, then it might be needed that you create your own policy definitions, but you get lots of policy definitions delivered from Microsoft. And then you can assign those wherever you need them. So the assignment of policies that somehow assess or restrict certain configurations are applied at a scope. And the scope could be a subscription. So you could assign a policy at subscription level, which means that this policy would count for all the future resources that live in this subscription. Or you could also assign a policy at the resource group level or even at the management group level. So that's totally up to you. So taking again the same list as from the first section, this is exactly the same. We then take this list and apply our policies or our business rules, saying, okay, so for this thing, we definitely want to enforce HTTPS in the future, or we want to audit all storage accounts that use a public endpoint because we want to know, okay, and so on. So we apply the different policies that we want to implement. Then we design these policies, and then of course we activate the policies. And then we are ready to start deploying storage accounts, to come back to my example. So let's have a quick look how this looks like. If I go to my Azure portal here, I built a very simple example. So you can see that there's a policy section that you can go to. And in this policy section, the most important information, of course, is the policy overview or that compliance dashboard where I can immediately see, well, how compliant am I according to my business rules? And obviously, I do a very bad job here, but for now, this is fine. We're not interested in all of these. We're interested in that one. So here you can see a so-called policy initiative that is obviously somehow assessing and auditing storage accounts. So let's get in there. Now in there, we should see that I added 2 policy definitions in there. So a policy initiative is just like, imagine a group of policy definitions. And in here, I have now 2 policy definitions. So one is a policy that obviously only allows specific storage account SKUs. If you ever worked with storage accounts, you know that if you deploy a storage account, you need to select a SKU, which is standard local redundant storage, so standard LRS or a standard zone redundant storage or geo redundant storage, things like that. And in here, I just configured and said, well, at least I want to have zone redundant storage. So zone redundant storage or higher. But local redundant storage should not be used in my case. And so I created this policy. And I also said, well, if someone tries to deploy a new storage account using LRS only, then this should be denied. And you can see that this policy assessed 2 of my storage accounts, so 2 resources, and obviously both of them are green, so are complying to my policies. And then I have another one that checks if I'm using customer managed keys for encryption at rest. Remember in the encryption section, we had the option that you just use encryption without any configuration, which means that Microsoft manages your key encryption keys. But here I decided that I always want to use customer managed encryption keys. So I want to use my own keys. And here I can now see that obviously I have 2 storage accounts and one is non-compliant. All right, so now of course I can dive in there to now understand, well, what storage account is affected? So what storage account is not compliant? Let's see. And in a second, I should see that this storage account, PSTO resource mastering 02, is obviously non-compliant. I could go into the details and I would see the same thing saying, well, you should use a customer managed key, but obviously you don't. Let's quickly go to the storage account section where I can see my 2 storage accounts. There we go. So number 1 was compliant. And you can see it from there. So this is using zone redundant storage. That's a requirement. And the second thing is the encryption part where I said, well, I want to use a customer managed key. And as you can see, this is configured. So this storage account is totally compliant according to my business rules. Whereas the second is not, because the second storage account obviously uses the Microsoft key encryption. Yeah, so I didn't configure anything. That's default. And now it tells me, well, according to your policy, you should use a customer managed key, but you don't. And now I can go and fix this issue. Now we also saw that I had one action set to deny. So that means that if I deploy a new storage account now, let me quickly do that. Deploy that into my resource group, just give it some unique name. All right. And then we said, I want to have zone redundant storage minimum or higher, which means that zone redundant, gear redundant, and so on will be okay, but LRS obviously should be denied. So let's quickly see if that is true. If I now just review and create, it's now validating that configuration against my policies, and it should give me back an error saying, well, this does not work because you're violating your policies. There we are. Validation failed. And now, of course, I can dive into the details and I can see, well, this guy was disallowed by policy. And I can also see like the policy and the initiative that actually blocked this validation. And just to be clear here, it doesn't matter if I use the portal to deploy this storage account, or if I use an Azure CLI script or the Cloud Shell or the REST APIs. So these policies are managed by the Azure Resource Manager, and they are active no matter what tools I use to communicate with the Azure platform. All right. Now what I've just shown you is the deployment of the resource using the Azure portal or the GUI version. And your deployment strategy. So how do you want to deploy resources or applications in the future? And what is very important, and that's also something that is missed a lot. I mean, deploying resources is important, but you really need to think about the full life cycle of your applications. So initial provisioning is one step, but then that's not the end of the story. Because once your applications are provisioned into the Azure platform, now starts the hard part, because now you need to maintain your applications. It will not just sit there and it will obviously be touched every now and then, because you need to make configuration changes. You might need to extend your application and so on. So you need to maintain it. And then one day you might even delete it because it's not needed anymore. So it's decommissioned. And when you think about a deployment and management strategy, always think about the full life cycle, because this will dramatically impact the way you will deploy your resources in the future. Don't think about initial provisioning only. That's the easy part. All right, so and because of that, what we normally suggest to our customers, at least when they have like a certain complexity in their environments and requirements, is to follow Cobased deployments. So everything that is deployed and managed should be done in a repeatable, very rock solid way. And this is definitely not the manual approach. If you do stuff as code, then you can, well, you can write your code, you can test your code in a test environment, and adjust it as soon as you're happy with the result. Then you bring that same code over to your dev or production environment, and then you will be sure that the result after you executed the code will be exactly the same, right? So it's repeatable, it's portable, and it gives you much more control, especially for complex applications. So if you imagine you have an application consisting of 30 different resources, then that's quite complex to configure in a manual way, because you not only need to deploy 30 different resources and configure all of them, but then you also somehow need to configure them so that they can work together. So that's a complex application. And if you have this as code, then this makes it much, much easier once you have your code ready to deploy and maintain that application. Now, as I said, think about the full life cycle and then decide how you want to approach this, because using code offers different ways. So there's different ways you can use code. And we mainly talk about the declarative and the imperative ways. So these are two mainly different approaches. So imperative is something that all of you definitely know. This is classical scripting. And in a script, when you create a script, you normally instruct the script what to do. So line 1, do this. If this is completed, go to line 2, then do this, and then do this. So you instruct the platform using, let's say, a PowerShell script, what should be changed, what should be deployed. In a declarative approach, however, you do not instruct what needs to be done, but you describe what you want. So you go there and you describe your application, saying, well, I want to have 3 storage accounts with these configurations. I want to have a virtual machine. I want to have a SQL database, whatever. You describe your full application with all the resources, with all the resource configurations, with all the dependencies. And then you hand over this configuration to the platform, saying, well, this is what I want. Please make it so. And then Azure will take care how this will be actually deployed and how it will be configured. You don't have to worry about this. And the real strength of the declarative approach is when it comes to the service maintenance part. Because for initial provisioning, you will find out that following an imperative approach normally is much quicker. Declarative is a little bit more complex. But when it comes to service maintenance, the declarative approach is much more straightforward, because if I want to change the configuration of my existing service, I go back to my initially declarative configuration file and I just change what needs to be changed, and then I hand over this declarative configuration to the platform again, and Azure will take care what needs to be changed to make sure that at the very end I have the result that I want. So it's up to you what you want to follow here. We normally follow a very strict declarative approach using ARM templates. But of course, at the very end, it's the customer's decision. It's important that the person or the team or the customer that needs to deal with that is comfortable with that. So it doesn't make sense to implement ARM templates if no one understands how this works. Then you either need to train the team or go for a different approach they feel more comfortable with. All right, and then what's very important here is once you decide to go code-based, you also need to make sure that your code is rock solid, that it's versioned, that it's under source control. So you also need to implement those processes so that you know your code is really controllable by you and your team. All right, and then once you have your code, if you're still in the development phase, of course, you might develop a notebook and then deploy that code to a test environment from your notebook. This is perfectly fine. But if you reach a certain stage, if you go into a, let's say a managed dev environment or an integration environment, staging environment, or at the very end, even the production environment, then you don't want to release code from your notebook, of course. You want to have a standardized, structured way to release your resources and your applications. And this is where the so-called release pipelines or just pipelines come into play, because they allow you to build a release process saying, well, at the very end, of course, I want to release my code, let's say an ARM template, to my production environment. But before I do that, I have certain steps I want to do before that. So first, I want to release the exact same code to a staging environment, because I want to check the results first before I hit the production, right? Or maybe even before that, you want to do some quality checks of your code, saying, well, I want to make sure that whoever wrote this code, it's written based on best practices. Then you can also do that in the pipeline, and saying, well, if this code quality checks fail, I will stop the pipeline. So that code will never hit my dev nor my production environment. But if all the tests are okay, we release that code to the dev environment, and then we do some checks, either manually or in an automated way. Maybe someone needs to approve before the pipeline proceeds to the next stage. But then finally, the exact same code through the same pipeline is then deployed to the production environment. So this is what the pipeline-based approach offers. And the cool thing is, once you have your pipeline ready, it doesn't matter who starts your pipeline. So whoever is has enough permissions to create a new release through a pipeline can do that, and then you will be sure that whoever started the pipeline run, the pipeline will always act exactly the same. The environment is always exactly the same. The only thing that might change, of course, is the code that is deployed, but the process is exactly the same. And no matter who triggers the pipeline, we will have a central place where we can audit all pipeline runs, where we can see, well, what has been deployed to what environment, who did the pipeline run, who executed that, and so on. So everything is locked into a central place. So let's quickly have a look at that. So when I develop code, I use, well, my dev box here, which is Windows 10 device using Visual Studio Code. And as you can see here, I don't have a complex example here because it doesn't make sense to demo this with a complex example. But this is a declarative ARM template that now just provisions one single resource. So normally in an environment, you would deploy multiple resources in the same template maybe, but this is just for one single resource. And you can see I have one resource here, one resource object. And of course, I need to instruct Azure, well, I want to have a resource of this type, which is storage account. I need to define what location, well, what Azure region the storage account goes to. This could be Switzerland North or whatever, US East and so on. The storage account obviously needs a name. The storage account needs a SKU. This is again the LRS, GRS, ZRS, and so on. And then maybe I also have tags. So this is a parameterized, simple example how you can deploy a storage account. But now if I want to deploy this, of course, I need to submit the different values for these parameters. So I need to submit a location value. I need to submit a name value. I need to submit a SKU value. And those can be submitted in a parameters file. Now you can see I have two parameters file prepared already. One for the dev environment, obviously, based on the naming, and one for the production environment. Because I want to release the exact same code to two environments, but of course I might want to use different values. So for instance, the name would be different in dev and in prod, whereas the SKU and the kind and the tags could be the same. So let's have a look at the parent files. So in here, I just have the values. So for instance, location, now this is the prod one. Location is West Europe. Name would be something, blah, 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 prod. The SKU would be standard zone redundant storage. The kind would be storage version 2. And then I have two tags. One is the owner and one is the environment. And then I have the same file for dev. The only difference is this. The name is a little bit different. And then the environment tag value is a little bit different. All the rest is exactly the same. And now I could release that code directly from my notebook, which is fine for testing the code, of course. So let me quickly show you how this works. So this is a way, and it's just one way, how you now can release code from your dev box to the Azure environment. So I'm using the Azure CLI here, which gives you this AZ command. I define I want to create a new deployment. So deployment. I define I want to create a resource group deployment. So that means I deploy this ARM template into a resource group. And then, of course, I need to define, well, what's the name of the resource group? As you can see, I'm using a parameter $G, which is this resource group up here. And I need to define, well, where is the template file? $F, which is my JSON file, and where are the parameters? the parameters file, which is now my prod file. Let me quickly change this to def. And then I use this option as well, confirm with what if, because this is also interesting. Let me quickly fire this. This is also interesting because this will check, well, if you would deploy this code onto the platform, you're not doing it yet, but if you would, what would actually happen? Because we remember code is not only for initial provisioning. I might have a change that is updating one of my already existing resources. And especially in that scenario, I want to know, well, what would change now if I would release this code? Because I wrote the code, I think I know what would change, but I'm not 100% sure if that's really the case. So using what if tells me, well, now in your case, I would add one storage with these parameters. So green means this will be added, because that storage account obviously does not exist yet. But I can also see down here, right? So here, one storage account will be created. That's the green part. And 3 other resources will be inured, because obviously in this resource group up here, in there, I have existing resources, but they are not touched by this deployment here. They're inured. And now I can finally decide, well, do I want to deploy that or not? I will now select no. I'm not interested in doing that. Maybe I found out, well, this tag here is not good. Let me go back to the code, change it, and then do a what if again. But what I want to show you is how this is done by using a pipeline, because that's the approach you should use in a production environment. And this is, where is it here? No. So when you create pipelines, of course, you first need to select what platform you want to use to build your pipelines. And I chose Azure DevOps and created my pipeline here. So let me go in there. And if I select that, I can see the past runs of my pipeline. So for now, I will just quickly run it, because this takes a while to execute. And now when I run it, I can immediately see, well, what is this pipeline actually doing? Of course, I should check that before I run the pipeline, but I already know. So obviously, I have the first stage, which is somehow preparing my code. Then obviously, I have a stage that, depending on the name, will release that code to my dev environment. And then the last stage is releasing the same code to the production environment. All right, so this is now running. And while it's running, we will have a quick look at how this pipeline is actually created. Believe it or not, the pipeline itself is also written in code, because we want to do everything as code, also our pipeline. So now let's quickly collapse this a little bit to give you a better overview. So this is how it looks like. So first I have certain variable values that I'm using. And here you can see that I just defined 2 variables for naming the resource groups. So the resource groups for the dev environment and the resource group for the production environment, because you remember we will release the same code twice. In this example, I will release the same code to the same subscription, but just in 2 different resource groups. All right, and then I have the 3 stages. So stage number 1, this will not go into the details here. This will test my code if it's written against best practices. And then the code is released to my dev environment. All right, and you can see here, this stage depends on the build stage, which means only if the build stage was successful, I continue with the dev stage. And I will then release the code to the dev environment. And somewhere down in this code, you would see, it's a little bit hidden down here, that I'm now deploying just my storage account JSON, and I'm using that dev parameters files that I showed you in Visual Studio Code. This is exactly the same code that I'm using in the pipeline here. So my JSON file, my ARM template, together with the dev parents file, because remember, we deploy to the dev environment, right? And then finally, I do the same thing. If dev was successful, I release the exact same code, but this time I'm using the production parent file, because now I want to go into the production environment and I will deploy this into another resource group in the same subscription. And what I also did here is I also implemented a manual approval. So I said, well, if dev was successful, that's perfectly fine. But before the same code continues to be released to the production environment, someone needs to approve it. Now let's go back to our pipeline run just quickly. So I can now see here, this is the run I started before. Stage 1 and 2 were successful. So let's quickly deep dive into that. I can see build was good. I can see 100% of the tests has been passed. I can also have a look, well, what has been done. 24 tests have been passed. You cannot see anything because it only shows the failed ones. So let's quickly see the tested, the test that passed everything, and then you can see what has been tested against my JSON file here. So don't use any admin usernames in clear text, very obvious. Use up-to-date API versions and so on. So that worked. Let's go back. Then the deployment to the dev environment was successful. So let's check that in the Azure portal. I will go back to my Azure portal and to my resource groups, and I should now see the DRGR Cloud 8, which should now already contain my storage account. Yeah, remember with that dev ending. So that's there. But we cannot see the production one yet. Why? Because the pipeline stopped and it's waiting for an approval now. So you can see here, well, someone needs to approve. The pipeline is waiting. And because it's me, I'm the approver, I just hit go and approve. And now it will go to the next stage and release that code. So cool thing when using pipelines. And then, of course, once your code is released, your application is released to the platform, you start managing your applications. Make sure that your resources are secure. So go to the security center, check out the recommendations from time to time. Think about implementing notifications for critical events and so on. And then you can, of course, also automate the operational tasks, which means if a certain alert is triggered in Azure, you could have a playbook that is then automatically triggered to fix that issue, right? And this is not something you need to build from the very beginning, but this is something that might be extended over time. So if you get the same issues over and over again, then it's time to think about, well, how can I automate this? How can I automate the remediation of this issue? And also important, make sure that the costs are not getting out of control. So make sure that you always analyze the costs, and you should also define budgets. So if you plan a full application and you know what resource types you're using, you also know approximately what costs will hit you by the end of the month. And then you should define budgets that also give you like spending alerts if you reach the budgets, so you can then analyze, well, what happened? Is this still okay, or am I definitely doing something wrong here? So that you understand that you will get high costs early enough so that you can act. All right, and then again, operational tasks. If you have specific tasks, I come back to the key rotation example I showed you. Plan those tasks, and if ever possible, automate those tasks. Make sure that whatever you automate here has no impact on your code. So you always need to think of, well, is this something I can just trigger and I don't need to adjust my code, or if this is something that I should actually do in my declarative code. So let's say you have a key rotation process. This has no impact on your code, so you can just do that. If you delete your full application and redeploy it from scratch, you're fine. But if you have, let's say, an operational task that changes the dimensions or the SKU of a service, then that's a bad thing, because if you re-release your code afterwards, that might again change what you change with your operational task. So you always need to think, is this something I should do in my code and then do a pipeline run and re-release the code? Or is this something that doesn't impact my code and then I can just handle it as an ops task and automate that as well? All right, and when you follow all of these 4 pillars, I think you're pretty much prepared So to quickly sum it up, we're already over time, I see. Important, make sure you understand your resources, make sure you know how they work, and you're ready to understand how to deal with different properties and different settings of those resource types. Make sure you have the proper policies in place. This is very important, so you can assess your resources, you can audit what you have in your environment, and you get a very quick and good overview if your resources are compliant according to your business rules or not. Deploy what you understand, of course. Deploy using code and pipelines whenever possible. So this is definitely something you should keep in mind. But then it's also okay to have exceptions, because not every company and not everything can be done as code. It's just, well, it's very, very hard to handle. If you are there where you really manage everything as code, perfect. Then you're top notch. But very often in many companies, we see like a mix of a little bit of everything, because it's just too hard to deploy everything as code, depending on the teams that are responsible. So accept exceptions if they are manageable. And they are manageable if you have proper policies in place. If you have a policy framework that makes sure that no one can configure a service in a way that you want to avoid, then you can do that using policies, and then having manual deployments are also pretty much okay. All right, that was it from my side. Thanks to the sponsors that make this this conference actually happen. So ScriptRunner, IT Point, and MB365. Thanks for joining my session. I hope this was valuable. Again, if you have any questions, I will still be around for some minutes. Otherwise, feel free to reach out using Twitter, LinkedIn, email, or whatever you prefer, and I'm happy to help you out. Thank you so much, and enjoy the rest of the show.